First of all, thank you for taking the time. I know everybody's busy, and it's been a wonderful day for us. So far, this is a real treat. And it's also a treat to ignore my cell phone for a half. So thank you for that. But I think it is a natural tendency. I'll talk about another dimension to that. Design and the idea of design is really a key part of the Olin curriculum. So if I had to give the elevator pitch, which actually is close to the truth, is that it's a design-centric, project-based curriculum, and it's design-centric in a holistic view of design. So the first semester you take a design course, and the design course is a project-based course, but it's more to get at some of these, at the issue of how does design work, and it's not just building. That you actually have to, first, observation. The theme of this course at the moment for the last few years, and as Rick said, everything at Olin has an implicit expiration date, so we're always trying to figure out to change it. This particular course is called Design Nature, and the reason nature is in there is because it has sort of a biomimicry theme to it. The first project is for the last 2 or 3 years has been hopping insects. And the first thing you do in that project when you walk in is we'll send you out with a pad of paper, sketch paper, out in the fields, and say, find a bug that hops. And try to figure out how does it do that? What does it really do? And actually sketch the bug, and what do you think? How do you think that is going? And then try to reproduce that motion, etc. But more just to get at those issues. I'll mention the second project, which has been hugely popular over the last few years, which is more of a team project, and then I'm going to get at this issue of design, and also going to bring analysis into this question. So the second project has been design a toy, usually with a particular theme. Design a toy that's cool for a fourth grader. So immediately they think, okay, we're going to figure this out, and we say, time out. What are you doing? We're designing a toy that's cool for a fourth grader. Okay, you're 18, 19, 17 years old. When were you in the fourth grade? When I was 9. So half a life ago, as far as you're concerned. Do you remember? I mean, is your mind right now calibrated to a fourth grader's mind, or maybe has something happened to you since you were in the fourth grade? Yeah. So why are you just talking to us? We certainly were in the fourth grade a long time ago. Mm-hmm. What we're going to do is we're going to go down the block and we're going to visit the fourth grade. And you're going to interview fourth graders and talk to them about what they think is really cool. And they're your customers. They're your audience. Figure out what that is. So then they go back, and there's usually a theme. Like one might be a water theme. One might be an underground float theme. One might be an animal that hops theme. And then they make these toys. And the final assessment, if you will, the final exam, is that the school bus pulls up at Olin. And the fourth graders walk off the school bus, and we hand the fourth graders clipboards with the toys. And we say, there they are. Go grade these toys. So you have never seen a crestfallen 18-year-old who thinks that they have designed the coolest possible toy, and they're standing there by themselves because there are 15 students gathered around Hannah playing with her toy and realizing, I just have completely blown this product development. I just completely blown it because I never understood my audience. And there's just some lessons learned in that. We scaffold in some design theory. We scaffold in some engineering skills, some CAD, some 3D printing, etc. Many of our first term courses, there's not a math or physics course in the first term. But there is math, physics, and other topics. They're there in sort of a sneaky, under-the-hand way, more from the motivation standpoint. So in an instrumentation course in the first term, they'll actually breadboard and design circuits. They'll have to design circuit filters. They actually build an EKG. And then struggle and go crazy trying to figure out how do you filter the signals you might get from EKG leads to actually pick up the signal that you want. And maybe if you want to make that filtering a little bit more interesting, you probably should try to analyze it. And if you use conventional mathematics and not complex mathematics, it's a pain in the neck. And so all of a sudden, after we let them struggle for a week or two, and we say, there's this thing called complex mathematics that will take those 6 pages and do it in half page. So now I've got a motivation to learn complex mathematics. So those are some of the things we scaffold. But we had another challenge which we're trying to deal with right now. And besides the build before designing, which, I think everybody has that tendency for, but you really have to. We found something else. We found that our design curriculum was strong enough and coherent enough so that by the time our students got to be seniors, we have sort of a senior design project on steroids, which I can describe. But we found when they did those senior design projects that they were so comfortable, skilled, or having confidence in design that they didn't have an analysis, so that they would ideate, they would synthesize. We had, the one thing I should have done before I came to Olin is invest in 3M, because we had post-its all over the place. And then we'd watch them. This is a year-long design project, and it'd be the middle of November, Thanksgiving would be approaching, and you'd step back, and we'd let it be their project, and you'd step back and say, there are still 50 alternatives on the table here, because they're pitching, they're arguing, they're synthesizing. The fact of the matter is, if someone would just step back and say, okay, we are going to analyze, at least in the first order way, these 50 different alternatives, and those 50 will go down to 5 in about a day, because of, just one, that somebody's violating some law somewhere along the line here, or just that there's too much complexity and they could do that. We found they didn't have the confidence of doing that. So what we're trying to decipher, and I'd love your insight into this with your own students, we thought one of the sets of issues there is that we were giving them coherent design experiences, very scaffolded, etc., but when it came to analysis, we were still compartmentalizing analysis topics, and they were not integrating at the same time. So now, well, this is an experiment. I don't know if it'll work. We've introduced a 2-course sequence, second semester, first year, first semester, second year, called Quantitative Engineering Analysis. And what we're trying to do there is a team-taught course where we're bringing in content elements from mechanics, our math sequence, which is called linearities, which involves linear algebra, differential equations, and some other topics, signals and systems, and dynamics, all in the same course in a project-based 2 or 3 projects a year, sort of scaffolded, and it is what we call a double-wide course, in the sense that Olin still uses a credit hour system. So all our courses are now in 4 credit hours, and so this one is 8 credit hours, and given it's the 2 terms, it's 16 credit hours worth of work. It's being taught by a team. When we get to the assessment, we're trying, which it's only, this is the second time around, so we're not going to see this impact. We'll have to, we've committed to do the experiment for 3 years, and now we're putting the assessment instruments in place to do this. We want to see if when you get to more complex design issues, do we actually see somebody or a group stepping back and saying, actually we can analyze this thing instead of coming up with design alternatives. That's our challenge. That's one of our challenge areas.
So in mechanical, when we do our capstone, we do it in 2 courses. We call one the pre-capstone, the other the capstone.
Yeah.
We do the capstone portion actually 1 semester plus 1/3. In the pre-capstone, we kind of force them through a structured design process with some portion of analysis, but there's not enough time to get to that.
Yeah, that's that makes sense. Our We have a primary senior design course, and then there's an alternative. The senior design program has evolved as being industry-sponsored projects. We have an alternative that operates more in the nonprofit area, so that's got a different model to it.
So one thing that we've done as a head and I over the past 5 years maybe now is when I was in ISC, Industrial Systems Engineering, we started an interdisciplinary capstone subsection, which Chase, I guess, is part of, because as just said, and that's been an interesting.
What disciplines are when
MECI and ISC.
Okay.
And so ISCs, I think, spend a little more time on analysis, but from a statistical perspective. But we're always driven by decision-making problems, and they're driven by design and build types of things. And so it's been fascinating over the years to watch the students. We come together, we have these meetings on a weekly basis, and we are just speaking foreign languages to each other.
Isn't that amazing?
It is.
I mean, it's not criticism, it's just
no, it is. It's really interesting because we'll have a conversation, the students will go away, and then we'll hear from our students, what did Dr. Shiab say? What did Dr. Sadiq say? Because we just have different approaches to problem solving. So I don't know if you want to say a few words about it, Chase, and your experience. It's early still, I know.
Yeah, it's pretty early. It's been interesting because, we know, okay, first we have to go to this facility, and we're working with GE. So they give us a problem, and we go in, and we have our notebook, and we're touring the facility, looking at what has been presented to us, and we come away with two sets of very divergent, problems. And so the MECIs would be like, okay, maybe we can redesign this seal, maybe we can redesign the machining of this operation. We're like, okay, these tools are in the wrong place, they don't have enough workers, and so we take a problem and we end up with two completely different sets. And so figuring out where those things kind of work together, where where the MECI strengths are, where the industrial strengths are, has been a really, really interesting challenge this semester. I've really enjoyed it so far, and I'm probably pretty lucky to have a good group and good advisors, but it's definitely been a great experience to kind of grow and to get some of that foreign language experience.
But so, I don't know how my faculty colleagues view this, but I think what you just described is a great success, because I think the other thing about the build is the idea that the outcome is the primary goal.
Yes.
I mean, the fiction. I mean, I hope this is not heretical, but and of course, I'm an engineer. I get it. We want to create things, and so and there's a lot of satisfaction in creating something. In fact, back to the more fundamental aspects. That's one of the things. If I can step back a little, as engineering educators, that we want to plug back into. Students come to engineering school for the experience that you just described. The idea of, yes, people who study engineering want to know how things work, but there's something about creating it that doesn't exist, and solving a problem that no one else has solved. And we have to plug into that. And you have to practice at that. But this fixation that it's the end product is so important. We're really, from my perspective, what we want to do again, this is at the undergraduate level, and something that didn't come up in the larger conversation, which I'm sure you all struggle with, is the process and content struggle. Where do you put the emphasis? So, to a certain extent, at Olin, we've made a call, and the call we've made is that for undergraduate engineering, we think that to a large extent process trumps content, and that's not engineering across the board. Certainly, we still need content experts. There's no doubt about that. We should be equipping our students with the ability to become content experts if they want to become content experts. But the experience that you just described, if you then go to GE or someplace else, this is what GE needs, and the insight that you have will give you a better career at GE. If GE needs better seals design, they will find somebody who can designing better seals. And if you think designing better, this wouldn't be criticism, that after you've had this experience, that actually designing better seals is what I want to focus on, that's fabulous. But it's the journey you took to that. So the idea of just having the different language, the different experience, is, I think that's what's critical.
I would submit that what you just said, that process trumps content, is the single biggest innovation out of the Olin experiment, and probably the hardest one to implement in any other environment.
And I don't say it lightly, because I'm honestly not saying it as a bomb thrower. I'm saying it as someone who is deeply interested in engineering education, but with a certain bent. That the idea that, if you want to unfurl a really radical idea, the really radical idea is that I think now that we were talking inside how we're all tribal anyway. So now with all the engineers around the table, I can say that as far as the academy is concerned, that as far as liberating and cross-disciplinary education, the engineering college is not in the background. That in fact it is the unit of the institutions that will need to lead this change across the institution. This is where it's going. This is where it's going to come from. The idea of opening it up and expanding this sort of transdisciplinary philosophy. I mean, there may be great pockets of innovation in different schools across the university, but at the undergraduate level, the engineering faculty, engineering college is going to have to lead this charge. It's not going to happen from the other units. I was at Tufts University for 26 years and became convinced of this.
You want to talk a little bit about the water?
I was just kind of almost a segue. We have I'm director of the Water Center, Water Technologies for Emerging Regions, Water and Sanitation for All, very much an developing country focus. And quickly realized engineering is part of the solution, but the easy part of the solution. Behavior, choices, why people do things the way they do, how to change habits. That's much more complex than the engineering side of things. So our water minor has students from engineering, all different engineering disciplines, working with anthropology, sociology, working with business, entrepreneurship, because we purport that the intersection of technology, entrepreneurship, business model approaches, and behavioral, cultural understanding is where you get sustainable solutions in developing countries. So it is quite interesting traveling to Ethiopia with an anthropology professor and a business professor. And it's great for me as a professor to see how they view the world and to see they look at things different than I do.
Yeah.
And
It's another very
that's
good
good.
experience.
That's good, and I learned by watching them, and hopefully better able to inculcate that into the students. It's challenging but exciting, and the motivation is wanting to solve a problem.
Yeah, do good for the.
I mean, infant mortality rates of 10 to 15% in countries today in our world. Child dies every 30 seconds from a waterborne disease that's easily preventable. And, the engineering is not going to solve the problem. It's going to take the working of those disciplines together. And so that's the motivation to reach outside of engineering and work with people from other disciplines.
That's one of my, it's a great focus. One of the things that, when I was at Tufts that I was involved with is we had a program that was very much what you described, and because of that intersection, it was called Water System Science and Society. And again, it brought together people from engineering, from the humanities and social sciences. At Tufts, it was the Fletcher School of Law and Diplomacy, and then the medical school. And the interesting thing, and then we eventually were able to get an NSF Eicher grant in just the water and diplomacy piece, because the interesting challenge, from your work, water has such an impact not only on health, but it has such an impact on national and international relationships. How many borders are water borders? I always say, being from the East, that if a civil war was going to break out in the United States, it'd be everybody attacking California for stealing all its water, stealing water from everybody else. But water is but it is one of those topics where the engineering and often where the engineering solutions, traditional engineering solutions, have been more part of the problem than the solution, because they're not easy from an engineering sense. They're usually, some of them are the nth wonders of the world.
Yeah.
But remains to be seen. No, that's great. Those are just the types of. This may seem like a little bit of non sequitur, but I think the other thing about, we talked about engineering faculty, students. Maybe these folks should speak for themselves, but I think that our current engineering students are just have a different set of motivations, a different context than others from the past. I think a lot of us who are faculty were motivated often by particular technology interests or particular sectors of it. Maybe you're a space age person or a car person or a computer person or the like. It was more of a technology. It's still I think engineers are motivated and interested in particular technology, but the idea of the connectivity and the idea of solving system level problems where the engineering is a piece is really an important, current something that we've got to speak to as far as that's concerned, and that's just a reality.
And I think as faculty become more diverse in our perspective and approach and our composition.
We all realize
better helps us to attract more diverse.
We all realize that
population.
as engineers, we all look at time constants, right? So the student is a 4-year time constant, and the faculty order of magnitude bigger. So if you want to do the dynamic analysis and figure out where the lag in the system is, find the one with the longer time constant. You'll see where the lag in the system is.
Hannah, do you want to talk about the leadership program and what you're about?
Sure. One thing that I just thought of when you were talking about that is that, so industrial systems be a little bit of like the ergonomics and human factor side, which I think a lot of other disciplines don't get. And it's kind of like the mechanical part that you're talking about, as you see the more people side, you see the design part. One thing that you look at in the leadership program a lot is different like personality types and how leadership styles and how those kind of intertwine and work together, especially in an engineering setting or an industry setting where you have engineers working with other people. And the leadership program is, all different disciplines and petroleum engineers and geologists. So you have a lot of different of the foreign languages kind of coming together, but then also connected by, well, let's think about what are our different leadership styles and how can we work together and how would you solve this kind of dispute. And I think it really helps connect people when you think of, well, how am I thinking about this problem and how are they thinking about this problem? Not only on the level of, well, how are they seeing the problem as an engineer, but how are they approaching it based on their experiences with other people and working in groups. And it's not necessarily like leadership is kind of a weird way to describe it because maybe I'm not like the manager, but it's still how are you leading your project or how are you approaching the problem in a setting, in a leadership setting.
Now, is that a program that's only available from your department or is that across?
No, it's across. When it started out actually really small in industrial engineering, and then the past couple of years it expanded to the entire engineering college and Newborn, the earth and energy, so it's petroleum engineering and geology.
And actually, Mr. Brock is a big supporter of the leadership program, so it's a nice intersection there for us.
Oh, that's great.
But, yeah, we piloted it in ISC, and then when the director in ISC finished her PhD in leadership, she took it to the college level. Has really expanded it, built off of kind of a legacy course we had with a retired general General Holmes, and has developed it into a really kind of strong academic component to think about these issues.
So now it is drawing throughout from the college and from this. And petroleum engineering lives in a different college.
Well, it's complicated, and we won't go into that, but the dean joined us this
Every
morning.
institution has these lovely stories of the Byzantine history that apply. Yeah.
But we still play together.
Oh,
Sometimes.
yeah.
Nicely.
Nicely, right?
Yeah.
So yeah, we include them as well.
Yeah. It's always the challenge, and when you go into the different work environments and realize there are very few institutions outside of academia that are organized like academia.
Right.
At least institutions that are still in business.
That's right.
So how big? How many? Like, what fraction of the students in the college are engaged in the program? What would you say?
Right now we have 77 students who are in it.
So we're in our second year of
Oh,
being
so
at a college level.
That's right. So that's good. That's good.
Yeah, that
so
sounds
that's
right.
good. That's good traction.
Yeah, it is good traction. And the goal is to expand it a little more, but part of the challenge is that we partner every student with a professional mentor.
Nice.
And so there's some things that just take a little bit of relationship building and time to scale up. So
I mean, that's the one thing that we were in the subset of us that were across the hall speaking a little while ago. When you go from a small place like Olin to a large institution, and our only secondhand experiences with Illinois and with UTEP, is that what we do organically, you've got to build a program.
Mm-hmm.
You've got to have structure. You've got to have a program. You can't just haphazardly expect all these flowers to bloom. You're going to have to figure out a way to do it. So it sounds like even this, with each teaming of someone as a professional mentor, when they hear that, say, there's a lot of work there.
yes, there is.
Because, and that doesn't mean that you've got to look at mentors. You've got to figure out who's going to be good mentors.
Yeah, and we learned that quickly in ISC when we were starting it with a smaller cohort. Just saying, oh, here's your mentor doesn't make a relationship.
Oh my gosh.
And so you have to really prepare, and you have to scaffold and do a lot of things to nurture that. So
How hard is that?
really hard. And sometimes it doesn't work. But we do a lot of, we know our alumni well for being
Is that a large source of your mentor
Yes, it
network?
is. Yeah, it is.
So a lot of these might be distance relationships.
Some of them are, and those seem to work really well with the technology available today.
Mhm.
So.
Yeah. I mean, even with our senior design projects that are corporate sponsored, often the companies are far off. For instance, Boeing is
Right.
Boeing City in Seattle is a sponsor. What we really insist on as far as those projects are concerned, that first of all, that the project mentors or advisors coming from the company are really committed
Yes.
to it. And we will not sign up a company that is probably the failure mechanism.
Yes.
If we want somebody on the other side of that phone, we want somebody who's actually going to take the email from the students seriously and answer their questions. And the other thing we work in is enough funding in the project actually to get the students to the site for multiple days,
Oh, nice.
so that they can to get a sense of what it is. We had our first this year, our first internationally sponsored. We were sponsored by Mitsubishi out of Tokyo.
Oh, wow. That's cool.
The Benny to those students who joined us.
Yeah, right.
Is that in January they were in Tokyo. So
Wow.
that was a nice experience.
Well, that's a good segue into study abroad.
Yes.
And I don't know what Olin does in study abroad, but
And nothing terribly organized, and it's an area that I'd love to hear more about as far as insight or lessons learned. The lessons that you've learned.
Well, again, because we're a larger institution, we do something with a lot of structure.
Sure.
It's not very ad hoc. There's been a lot of effort put into it. So ours are fairly organized, and we implement this. A lot of universities will sort of farm out the study abroad to companies that provide those services. For our engineers, in order to ensure that they can get
Course
University of
equivalencies.
Oklahoma ABET accredited courses abroad that don't slow down their graduation and so forth. We've worked hard to implement a system where our faculty can go abroad for some amount of time and do the teaching. So there's a load on the faculty in terms of developing relevancies within the course. You can take statistics anywhere. Why go take it in Italy, right? And so what can we do to make taking statistics in Italy or statics or my course that I teach, somehow relevant to the local environment and culture. So we've done a little bit of work. In fact, Dave's going to teach one of our courses in Arezzo this coming fall. So I've been talking with him about what he's going to teach and how my measurement and instrumentation class, maybe I can develop one project that ties into what he's going to teach, so the students have some sort of connection from course to course rather than just the way we've done it is kind of unique. We don't send engineering professors abroad for an entire semester. Most of us have research programs as well, sure. and it would be difficult to do. The students are there for an entire semester, and we teach the engineering courses in 4-week blocks, like summer school. So it's a very intense, my class, and then statistics, and then statics, and then his course. And to try to prevent them from feeling really chunky and isolated, we try to look for cross-disciplinary ideas that we can share across the 4 courses, to try to have projects and related topics that help the student sort of bridge that gap and find some interest from one course to the next, rather than it just being sort of this bullet approach. I've got to do a core dump on this date. Tomorrow I've got to start a new class, kind of thing.
Now, most OU students that who go abroad are going to programs that have this embedded OU faculty?
They've got some kind of embedded system. We have our I don't know if I'd call it our flagship program. That seems to be the word used. Our flagship program is our campus in Arezzo, Italy, which is in central Tuscany. And we have dorm space and classroom space, and they're there for an entire semester. A lot of them will take the art history course that's offered. And one of the other professors and I got the college to agree to fund museum admittance for all the engineering students. So we require, whether they're taking the class or not, we require them to go on any field trip, because it's dumb to fly all that way and then not go stand right in front of the David and have some guy that really knows a lot about it telling you about it right there, So we make them go on the field trips even if they're not taking the class. But then we've got a program in France that's a 6-week program, and the leadership professor, Dr. Wolfenbarger, and I are going to teach that this year. That's done in conjunction with the University of, it's not the University of Blaise Pascal anymore. They've merged with UCA. They keep merging and unmerging and doing lots of things there, so it's all very confusing about what to call them on any given day. And then we've had a program in Brazil, Puebla. That's the other place where we're building, Puebla, Mexico, where we're building an infrastructure to deliver courseware from OU professors.
That's university-wide. All those 3 campuses, I guess, Arezzo, Pueblo, and...
Yeah, these are university-wide. So in Arezzo, for example, in any given semester, the engineers might be a third of the total student cohort, and you'll have art history majors, political science majors, biology
This
majors.
is a different type of model, and I like the idea of the structure of you sort of scaffolding it for the students, so they're just not willy-nilly going.
Right.
And it's a nightmare of the course equivalency is in trying to figure out what they've established and liking, and the faculty knowing the institutions firsthand.
Right.
And,
At OU, we also have a program called Journeys that any faculty member, it's primarily humanities and social sciences faculty members, but any faculty member that's familiar with a particular area can propose a course and take a small cohort of students there for, oftentimes it's a social engagement project, or as well as learning about the culture or whatever the topic area is. And those are usually about 3 weeks long, and they can go anywhere in the world. They don't have to go to one of these campuses.
No, it's really a great idea about this time compartmentalization, because springing somebody for a whole term either for their own agenda or from a deployment standpoint that's a big challenge. What about internal to the university? Are there any university level initiatives in cross-disciplinary teaching or programs across the schools? Is that part of the conversation or not? I don't mean to, but I'm always interested.
One example that comes to mind is to have something called President's Dream Courses. And those are they often encourage people from different disciplines to come together and offer a dream course, and they have funds to bring in national, international experts.
Dream in the sense that the faculty would have loved to teach it. Who was dreaming?
Dream up.
The dream. Yeah.
They're one-offs.
Yeah.
We have some programs. I think of like Women and Gender Studies, and I think African and African American Studies started this way, where they have faculty that affiliate through a lot of different home departments, but have a common interest. I mean, we're both affiliate faculty in Women and Gender Studies. So while we're not teaching there, some others are more involved in that mechanism, but we are part of the governance, we're part of the decision making and the activity programming. So we have some of those programs across campus. We did start an interdisciplinary master's degree in engineering, and I know that's not really interdisciplinary, but it's still groundbreaking at an institution like this.
No, please don't apologize.
It's a collaboration between computer science and ISC. And so we have a graduate program that has its own identity as a data science and analytics program, and that's funded actually centrally. So I think there's more effort, but we're still really mired in the departmental tenure and
And I would say the largest cross-disciplinary thing would be CCEW, the entrepreneurship program that's a partnership between the Price College of Business and Gallaudet College of Engineering.
One element that I'll mention a couple of things, but when we sometimes work with other schools, we realize there's almost a necessary, probably not necessary and sufficient, but at least a necessary condition when somebody is going to try to bring about systemic changes, that typically you need at least 2 components on the human side. You need, whether it's a younger faculty member or a more established faculty member, but the person with the fire in the belly for the change. But then you need the senior faculty member, department chair, dean, or whatever, who will both empower that person and run cover for them in the larger institutions. And you need to have those 2 components, and maybe you'll be successful. That's not for sure you'll be successful, but you need those components. And back to we have, at first they were just experiments, and now I think we are trying to peel apart from a more fundamental standpoint. We're really interested in integrated learning. Not only that course I was describing before, but relatively disparate disciplines of how to bring them together. And our first manifestation of it was a pure accident. And then I will describe what has happened since. So about a decade ago, we had 2 younger faculty members. One happened to be a material scientist, and the other was a historian of science and technology. They were hired at the same time. It's a small place. They probably sat around tables like this. And they came on their own. Their dream course evolved just from a conversation that they had. And they said, is there a way of teaching material science and history at the same time? And to make a very long story short, they pitched the idea of a course that eventually became known as the stuff of history. And the way they structured it was that this was going to be a history course that was taught in a material science laboratory. And what they would do is they would move through, there'd be a set of 3 or 4 topics where a particular historical era was going to be the focus. And so it'd be everything from the Bronze Age to colonial America to something else. And they would, the historian would talk about what's going on in society and then make the connections as to the materials that were available to the society and how those materials could be manipulated, in fact, impacted the society. And because of this, you had to live here. Because of that, you had to do your agriculture there. Because of that, you didn't communicate with this group, or you could communicate with this group. And then the students would actually step back and would say, and they then would learn the material science and say, okay, what's this Bronze Age all about? Let's figure out and let's make the bronze. Let's test the bronze and see what its properties are. And then we layer on top of that the language issue of saying, it sounds like these are disparate languages, but if you look at what goes on in material science lab and you look at how a historian approaches their topic, what a historian is calling evidence, you're calling data. What you're calling, what you're trying to represent in a report on a materials characterization is how a historian puts together their data and their interpretation for somebody to use in the future. So the historian in all this has become the master of this and has now worked with other faculty members. So a few years ago, we created, and material science is one of our required courses, so this counted as a requirement towards the material science program. So a few years ago, he partnered with we have a required biology course, and he partnered with a biologist, again for an 8-credit course. And this course is 6 microbes that change the world. And again, it's a really deep course in cell biology, but one of them is like cholera. It's E. coli, etc. And this fellow, his quirk is that he loves the number 6. So there's nothing magic about the number 6. It's not a biblical number. It's etc. Just loves the number 6. His regular course is 6 books that changed the world, of course. And but in the biology course, actually only 5 of those microbes are specified, and then the students for their project, they picked what was the 6th microbe that changed the world. And so some have historical precedent. A few years ago, you might expect that Ebola had a lot of conversations, but just this idea of integrated learning across what are disparate topics, in a sense that just for the students to have the experience, and the fact that you can't do this for every course, and there's some things you're not going to be able to do that for. But we find that it's also a little bit of a energy and adrenaline jolt for the faculty, because all of us as faculty, we're actually. So here's part of the inside story of being a faculty member. All of us are people who loved being in school. Except for maybe going off to industry every once in a while, being in school. So the idea of almost going back to school and learning a topic from an expert in this sort of way, to a certain extent, is an elixir. And so just to give people the opportunity of doing that. So it's great there are these dream courses. I hope that there are more of them so that people can invigorate themselves.
So I'm curious, you talked about some of these like stratified courses and the different kind of motivations of blending these different disciplinaries. What does that do to your transfer students and figuring out where a student is within your program and doesn't?
This is a really insightful question. The question that you're going to be flawed at my answer. We don't have transfer students. This is one, which is not a good thing. it is just it's a really insightful question. We're scratching our heads about that right now. There are a number of so to think about transfer students from a real practical sense, and before I even get to the pedagogy aspect, there's a fundamental weakness to the system that we've created. The fundamental weakness is that as far as our student body size, if you don't have transfer students, all you can do is attract. Right? There's nothing else that if you're not going to have an inflow, life is going to happen, and you're going to. And the other thing about Olin, again, it's an incredibly small school. One of my Olin colleagues I've been at Olin for about 6 years. I was there for about a year, and one of the more senior faculty members pulled me aside and said, "Vin, you started doing a good job. It's okay. We'll keep you as provost. It's all right." But there's one thing you haven't gotten your arms around. You're used to thinking in the continuum, and at Olin you have to think in quanta. So I said, okay, I got it. So one of the issues is the curse of small numbers, and which gives you wild statistical variations. So when you have small numbers, the mean is less important than the standard deviation. But in addition to that, what you have with our student body is this constant shrinking, and how do you actually bring new blood in and people who might be interested? So we're trying to figure out where the plug-in points now, especially that we have front-loaded so much of the curriculum in the first three, so that the overlap. So Olin, it's amazing. We've had this engineering conversation, and ABET only came up once. So let's bring up that 4-letter word. As far as we have 3 degrees. They're all engineering degrees, and they're all accredited. One is a mechanical engineering degree, the other is an electrical and computer engineering degree, and the third is a general engineering degree. So general engineering degrees. I don't know. Do you have an accredited general engineering degree?
No, not anymore.
Not anymore. You used to. Which is not surprising because it used to be other on the list, right? And mechanical engineering, I come from the mechanical engineering world. Mechanical engineering is the one up from other. No, I don't want to be that. I don't want to be that. Okay, be mechanical. Okay, so you fight out for other. But the fact of the matter is, and I can talk about this in more detail, that between requirements and overlapping elective spaces, the fact of the matter is that we only have 1 degree. We have 1 degree that for a certain set of students, if they do their electives in a certain way, they have enough mechanical engineering that if we squint our eyes and hold my hand the right way, I can clear the bar of ABET on the SME side, similar in the EC side. There's the average, if I look at transcripts, if we analyze the journeys that our students have been on, every Olin student overlaps somewhere around 75% as far as their coursework is concerned, even though they're on the 3-degree programs. So that that's an aspect that does come up. It would be really hard. So first, Olin is very small. So you might ask, especially at a major university, first of all, there are various levels of questions. Why ABET? Why those courses? Why not something else? There are some disciplines that we don't have, and they're deliberative solutions for a number of reasons. So one area, so we're not big enough to, even though I think there'd be a great deal of support for a degree program that would certainly have a lot of systems engineering to it from what we do, certainly from a philosophical standpoint. So we don't have chemical engineering. That's a big not have. And there are 2 major reasons we don't have chemical engineering. Size is a common reason for why not. That 3 is even too many. But why not chemical engineering? 2 reasons. One, from strictly a physical plant and operation standpoint, chemical engineers usually have big expensive toys that need watering and feeding all the time, and we just didn't. We weren't going to go there. On the ABET side, I don't know if we have any chemical engineers here, but
I don't realize we don't.
but even as, and I'd love to have sometime, maybe over a beverage other than coffee, a conversation of where ABET is heading these days, that even when EC 2000 had evolved, as far as the discipline is concerned, the chemical engineers held on to most of the other fields when you read there, the general requirements, the A through K and the objectives and et cetera. And then you go to the various, and most disciplines have a very concise, maybe couple of sentence, you should cover this and you should have that. And the chemical engineers have thou shalt, thou shalt, thou shalt, thou shalt, thou shalt. You have everyone, you cannot, you have to have the third course in transport phenomena. So we threw up our hands and said, there's no way to innovate in this space. It can't happen. Civil and environmental engineering, that was also driven by size, and I think that was a little bit more focused on the local business and industrial ecosystem of the Boston area. So if we looked at the sweet spot of the Boston area, it's a place where mechanical and electrical and software play together well, because that fuels either various parts of high tech or certainly biomedical devices and systems, which is a sweet spot. And then to a second order degree, civil engineers, at least traditional civil engineers, also have rather large lab requirements and toys to play with that we wouldn't have the infrastructure. We wouldn't have the infrastructure for. So we're accredited. There are very few funny stories that we all have about ABET. My only funny story about ABET is they'll be back in the fall of 2018. Next year will be our.
We're up this year.
For the visit, so they're coming in October of 2017.
Yeah.
Well, at least they didn't muck around with the requirements. They kept everything, and they are going to continue to talk about this ridiculous thing that they're trying to do. So 6 years ago, as you know, when you prepare your self-studies, you have to do a report for each program because we have this ridiculous system of undergraduate majors. But anyway, so I called up our friends in Baltimore. I said, at this funny school, we've accredited already, but do you really want 3 reports from me? I can write you one report. Write one, not me, the faculty. We'll write one report, and there are a couple places where we'll have 3 subsections. But so it's a very interesting question. We'll get back to you on that. So 2 days later, they got back to me on that. They said, no, we want 3 reports.
Did you have 3 commissions?
We had the representative. We had not 3 commissions, so we don't because if people do computing, we had a representative of each discipline as part, and then the team chair. So if our students, we don't have a computer science degree. If our students are interested in computing, they do the general engineering degree, and then they focus there. So okay, so of course I wrote one report and just changed the name appropriately. And said to them, that Appendix A or whatever it is where you have to list the faculty? I have no departments. I've got 40 some odd people. I've got mechanical engineers, I have electrical engineers, I have mathematicians, I have an anthropologist, I have a psychologist. What do you want me to do? And they said, well, we don't know what you should do with that. So what I did, I said, I put all our faculty in each appendix. And I said to them, if you can tell me which program they contribute to and which one they don't, tell me, because I can't. So do that. Now, to a certain extent, this is a little bit of bravado. Olin is in a special place, so to a certain extent, I feel that part of our mission is to be a little bit provocative, because we have so that's not pride, that's not doing this, it's just, I feel if we can't, at the same time, I just wonder, in the direction that they're going, whether a revolt is always percolating beneath the surface all the time. I mean, I have friends and colleagues, you probably do too. I can imagine that one of these days, if you've heard, I don't know if anybody's in electrical engineering Stanford, they nearly had a revolt the last time around, and I think they're just about at that point to say. But ABET, international accreditation is a growth business for ABET these days. But I think they've taken their eye off the prize.
Well, in industry, ISO certification became a growth business too, right?
Right, exactly.
You paid your money and you got certified. So I'm not sure how much good it did after a while. You were just paying your money and getting certified.
And there's so much good about the ISO process that you should be able to adapt. But when it becomes something different, is when you run into a problem.
I was going to ask one more question. Since you're the provost and I'm in mechanical, we always have the problem of diversity. I know for your case it's probably not. Do you address that?
I should say that can you be a little bit more specific about what you see as your diversity challenges?
So one is, of course, attracting female and minority students, especially for mechanical.
Yeah.
That's one. And then once we get them mechanical and maybe civil, not the environmental portion, the traditional disciplines, also keeping them in.
Yeah.
Because we don't have them. Do you have any comments or?
Well, certainly, to be honest, you put an end. You said women and underrepresented underrepresented minorities in the sense of racial, ethnic, to a certain extent. And in Olin, it's not an end. Those are two very different issues. So Olin, at the moment, is gender balanced in the undergraduate population. We're 50% women. And I'll tell you, I'll give you a peek under the hood as far as how that comes about. But actually, to your question, as far as the discipline is concerned, if we had a very mechanical engineering degree, it'd be more of a challenge. So since it's mechanical engineering without, but I think the fraction. What's the fraction of the female? I mean, you must know this. What's the
in the college?
In the college.
24.
24. Very good. Is she right?
Yeah.
Yeah. So that's which is measurably above the national average, but probably within the departments, the distribution is skewed.
Yes.
That's also the tradition. Certainly bioengineering made a huge factor there. Which is close to, but it's still a healthy fraction, 24%. I mean,
but you see industrial at 45 and higher. You see chemical at 35 and higher. You see mechanical at 10.
10. Well, 10 is really
Civil at 10 if you don't include the environmental
exactly.
science.
So that's
probably even lower.
Yeah. So
Yeah,
that's that's really extreme, and it has to be from the two. I think it's both from how the program is structured and how it's perceived as far as the identity is concerned, but actually just the demographics, when they're that imbalanced, are just a bad dynamic. I mean, but I'll even tell you about Olin with the gender balanced population, which was a design constraint, which I can describe. And there's still issues, but in most situations, I mean, the social scientists say, and I think there actually is a data supported conclusion, that when populations get to somewhere on the order of a third of a group, all of a sudden, just statistically, it's not a minority population anymore. Is that you will rarely then run into the situation where you will be the one of in different in environments. So the good news is 24% is not. 10% is a scary statistic. 24% is I actually can see that event horizon. But so how do we get to gender balance? And I'll talk about the underrepresented minority issue, which is the one that pains me more. The idea of 50% gender balance was a design constraint. It's not in the founding precepts of the school, but it goes way back to it is an explicitly stated goal. So how do we achieve that goal? Our admission pool is not gender balanced. Our admission pool is on the order of 2/3, 1/3. Now, what that means is that we want to have a rather large admission pool so that it's large enough so that we can have a gender balanced pool where the women are as qualified as the men. The depth of our pools are very different. We're going through this right now, as you probably are in your own admission process. Is that no offense to the male applicants, but so a young man who wants to come to Olin, we offer admission, and for some reason he says, okay, I'm going to go to Harvey Mudd, or I'm going to go to Georgia Tech, or whatever. We say, oh, gee whiz, he was really good. That's really a shame. Who's that other guy? Who are the three other guys that look just like him? That's fine. A young woman says, Rensselaer Polytech has just decided to give me the keys to Troy, New York, because to come to our institution. And we're on the phone. Well, oh my gosh, you got to come to Olin. We really want you there because we will only be gender balanced as long as we can be qualifications balanced. So that's just sort of that dynamic. The small school is a challenge on the underrepresented minorities because you're always easy to be one-ofs. We have a new admission, and Olin is a relatively new institution, so you have to realize it went through a history of the first group of students. Olin didn't even know if it could attract students, let alone a diverse group, or could it even attract students. And then almost too fast, Olin got on the list. And the list is the list that when some highly qualified student body, students are looking to go to, especially people that are interested in private education, and all of a sudden it started to appear on the list. So in no way are we comparable in any way, shape, or form to MIT or Caltech or Georgia Tech or whatever, except in admission. Those are our, and the engineering IVs, MIT, Georgia Tech, RPI, Caltech, Mudd, Rose, Holman for a little bit. Those are our admission overlap groups. They're not our overlap group in any other dimension. But once you get on the list, then it also the students don't differentiate. They don't differentiate as well. The small size also means that we can't take traditional approaches, for instance, things like the POSSE program, as far as underrepresented groups are concerned. If you're only going to enroll 90 students in a year, to have a different admission process for 10 or a dozen folks that come from a different background has all sorts of baggage associated with that, as far as their view of themselves, the view of others about them, and so that's something that we're really scratching our heads about. Where the small size is, for that we are not right sized. We are too small.
Well, we've overextended our time.
Oh, that's been
Very much appreciated.
You've overstated it very much. That's from your standpoint. This is very good. Thank you for sharing the time.
Yeah, we appreciate you.